Hi everyone, just wanted to take a moment to talk a little bit about conic sections and in particular in this video, circles. So conic sections, those are, as you would probably guess, the parts that can be made from cones. In particular, we have circles, which is pretty straightforward if you just cut a cone horizontally. We have ellipses. That is kind of if you cut at a bias, if you will, or diagonally. Hyperbola, which is if you took two stacked cones where the vertices of the cones are intersecting and cut straight down, you would get almost two uh, opposite parabolas, if you will. That would give you a hyperbola. And the last one is going to be the parabola, where if you cut along a diagonal, except going up towards the base, you would get the parabola. So they all have different features. They're all kind of related to quadratics, and they all largely kind of relate to the idea of having to complete the square to find components of them. But they are all slightly different and have their own little intricacies. But we'll start with the circle. So we've talked about circles when we talked about some of the geometry behind them. We did go into that the equation of the circle is essentially just going to be a derivation from the distance formula, right? Because if you took the square root, you'd have that the radius is the square root of x minus h squared plus y minus k squared, which you can see very clearly is very close to the distance formula, just with h and k instead of, x2 and y2. So the equation of a circle is going to be the radius squared is equal to the x minus h squared plus y minus k squared, where hk is your center point. Um, Now, you won't always get it that way. Sometimes you will get it in this general form down here. In this form right down here, that's almost kind of related to standard form, if you think about it from quadratics, back where you would have ax squared plus bx plus c. And there was pros and cons to having it. And having it in this way is kind of related to that standard form. There are pros and cons of having it this way. But for the purposes of graphing our circle, we will need to convert, which means that we will have to, do everybody's favorite, complete the square. Now, as I have been describing with my algebra classes, completing the square is kind of like the method of solving the quadratic that's like making the pie from scratch. It's really nice. There are a lot of situations where that's so much better and you can see visually where it's coming from, but it is a little bit more work and you do have to kind of manage it in the best way you can. So what we're going to do to complete the square, because again, we want it in this form. We want it in the form x minus h squared plus y minus k squared equals r squared. Okay, so we want to get the x's together and the y's together. So I'm just going to rewrite this. So I have x squared minus 4x. I'm going to leave a space. Plus y squared minus 18y. And I'm going to bring the 36 over to the other side. And the reason I'm doing that is because we know we're going to want anything that's not related to x and y on the other side. Over here, we want that r squared. So I'm just going to do that now for simplicity so we don't forget about it and accidentally add it in the wrong place. Now, with completing the square, if you look back at the completing the square video, the steps ultimately come down to you do b over 2a, you square it, you add it to both sides, and then you're doing that to create a perfect square trinomial. Now, this is nice. There's no a value here. Or I shouldn't say there's no a value. The a value is 1. So really, it just in this case ends up being, right, negative 4 over 2. Then you're going to square it. So we get negative 2 squared equals 4. Right, so we have to add 4 here, but we also have to remember to keep our equation balanced, I have to add it to both sides. So I have to add it over here. Now, we can't just do it with x, we have to do it with y because we also want y in this perfect square trinomial factored form. So we have to repeat. So negative 18 over, again, a is 1, so that's nice. to be perfectly honest. When a is not 1, you're not happy about it, but it's very similar. And we'll take a look at what that looks like. But it'll be -9 squared equals 81. So realistically, when you kind of go through this process, you do start to figure out kind of what it looks like, right? You know that a lot of them come out to similar numbers or the same numbers repeatedly, so you do kind of get used to it. Um, but again, the reason that we're doing this is to get these perfect square trinomials, because when you factor this, it just ends up being x minus 2 squared, right? Because if you do this out, factors of 4 that add up to -4, well, that's -2 and -2. So you get x minus 2 squared. Now, if you think about it, that's exactly what we were doing. We were adding this -2 in here, right? Or this -2 squared in here, for the sheer fact that that's what we were trying to do to begin with. We were trying to find it so that we could complete the square. We wanted that perfect square trinomial. So we did that -2 squared. And if you look at it, this -2 here is the same as here. So kind of using that same reasoning, right? This would be, we did a -9 squared to get the 81. Oh, well, we did that because we wanted x minus 9 squared. Now it's just a matter of simplifying this. Okay, so that's going to end up being, all right, what? Well, -36 plus 4 is -32. -32 plus 81 should be 49. So then we have our circle. We have 2, 9. That's lovely. Go over 2, up 9. 1, 2. Okay. So we have over 2, up 9. Don't forget it is the opposite. And then our r is going to be the square root of 49, which is 7. Now, unfortunately, I'm going to go off my graph here. 1, 2, 3, 4, 5, 6, 7. There we go. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It's up here somewhere. It's good enough. 1, 2, 3, 4, 5, 6, 7. All right. So I'm not asking for perfection here in your graphs. Obviously, you can tell that that's not great, but it's good enough. I can see clearly that this is supposed to be 7, 7, 7, 7. As long as I can see clearly that you're making that attempt, that's fine. Now, let's take a look and see. But ultimately, that's kind of what you're going to do for all of these, right? If you repeated with this one, you're going to go through the same process. Again, you're going to have the x squared, the x together. Squared minus 6y equals -16, and you're going to go through the same process of completing the square. But ultimately, that's all there is to circles. I think they are the nicest in the fact that they really don't have any sort of special, like, oh, this one goes further this way or anything like that. It is always the same distance. So let me know if you have any questions, and have a great day.